right, there you go.
Okay. Hi, welcome to another VC Libraries Open Code Review. I'm Stefan Tilawade, an STL maintainer, and today we'll be looking at a PR for CS+23. So let me go ahead and share my screen. Okay, so the PR that we're looking at is 2032, Stop Overconstraining Allocators in Container Deduction Guides from our contributor FSB 4000. As usual, this links to the issue that we filed, the tracking issue, for each CS+23 feature that we're implementing. We also have these for CS+20, defect reports, and LWG issues, all the stuff that we need to do. This issue captures our top-level summary of what we need to do. So it links to the paper that was voted into the standard and any other notes that are relevant. In this case, I always like to note whether any feature test macros need to be implemented because they're very easy to miss otherwise. In this case, there is not. Okay, so this paper is talking about container deduction guides, and I have mentioned the mysterious acronym CTAD. So we'll get into that. But if you would like to learn more, I actually did a talk about this CS+17 feature that we implemented a while back at CPPCon 2018. And CTAD stands for Class Template Argument Deduction, which is a mouthful, so I like to abbreviate it. And it is a generalization or extension of the ordinary template argument deduction that works for functions and has since CS+98. In CS+17, this started working with classes. This was a core language feature that was added relatively late in CS+17's standardization and was extended at the very last moment to the standard library. And we got that implemented in MSVC. And there have been I would say, a fair number of patch papers in the standard and LWG issues that have fixed up various ambiguities that we've noticed, because although I believe that it is a very useful feature and it's relatively straightforward most of the time, it can have interesting corner cases because we've never really had to think before this appeared in CS+17 about how class template constructors could participate in template argument deduction, because that just didn't exist before. So if you want to learn all about it, I recommend watching this video. The slides are also linked. The slides are also relatively self-contained if you like to read faster than watch a video. But I can give a quick demo of what CTAD looks like before we actually get started looking at the paper. So the idea here, I've got just a little hello world here. It's got to be compiled in CS+17 mode. So imagine that you have something like a vector of int v, and we're going to initialize it with some ints like this. Or actually even better, this is actually my favorite. Let's use a std array. Okay, so I'm going to say that we've got 3. It shouldn't be called v anymore. Okay, now we're going to print every element of this. Should always iterate in place. So for const.ref, the element in the array A, I would just like to print that out. New lines are fine. Okay, so this should totally compile. And it does, and we get 112233. Now, having to specify the type int, and especially the number of elements in here, is annoying. We have the ability now to just say, auto, idx is, some value, and we can get it deduced. We've got type deduction for just ordinary variables, and indeed that's what we did in the range-based for loop. If we call a function, if we had like a template on type name t, void print taken const t ref, and I won't even write out the rest of the function. When we call print, we know that we can just call it with some value, or we can call it with anything that the function is prepared to handle. We don't need to pass an explicit template argument to tell it what the type is. The compiler can deduce what it is. But when we work with a class template, we always have to say what types we want, and that's what CTAD solves. So in CS+17, you can drop this. You can just say, hey, compiler, I want a std array. Here's some stuff to initialize it. And please just deduce what std array that I want. The compiler knows that it needs to do that because it's going to see that std array is a template, but you have not provided any template arguments. So if we try to compile this in CS+17 mode, let's make sure I'm looking at the updated file. Yes, and let's compile. There we go. It works. So the type that we get is array of int, comma 3, initialized with these. And this is powered by class template argument deduction. And specifically, there's a deduction guide in the library that makes this possible. So deduction guides, let me change to a simple example before and this will be the last thing I show before we actually get to the paper. I don't want to redo my entire CPCon talk from memory. So if you have something like type traits, imagine that you have like the world's simplest pair, template, type name A, type name B, struct, and I'll say, don't have auto wrapping here, struct, my pair. We could have an AA, a BB. We can have a my pair constructor, take an A and a B, initialize them. Here I'm specifically not using references just to make things simpler. Yeah, looks good. Let me shove this over to the side. Okay, so that looks like a class. And then down here, we can have a my pair of, let's say, int, and let's keep it core language, Constexpr star, P initialized with 1729 and meow. Okay, I'm not actually going to do anything with P, so I'll just void cast it to silence any warnings. But I would like to static assert that I know what the type is. This is going to be trivial at first. So static assert that I'm going to need to say these things are the same. Is same v. The decal type of this P is a my pair of int and constchar star. Yep, that looks good. Let me move this terminal down to the bottom. This is so cool. Okay. There we go. So this should compile, unsurprisingly, because I have simply asserted that the type of the pair is what I declared it to be. And I screwed up something. What did I screw up? Illegal member initialization. Oh, I typed capital B, it's lowercase b for the member. It compiles. So with CTAD, CTAD will work implicitly. This is the cool thing. So in CS+17, I can just say, hey, I want a my pair of P. And yeah, it's totally a template on A and B. I'm not going to tell you what A and B are. I'm just going to give you an int and a string literal of type array of 5 const chars. I would like you to deduce that I want a my pair of int and const char star after decay. That's a classic CS+98 thing, decay. So now if I've saved this, let me double check that it's saved. It is indeed saved. So I've got my pair P without any arguments. I can compile this and it compiles. So notice that the compiler has deduced what my pair I want. And I've gotten my pair int const char star without having to mention CTAD anywhere. I have not done anything, not lifted a finger to make this work. And it did work. So that's cool. CTAD works implicitly a lot of the time. And the idea is that the every constructor generates what's called an implicit deduction guide that then the compiler uses using the same rules as function template argument deduction that we're familiar with as CS+ programmers. But this doesn't always work. So the case where deduction guide or implicit deduction guides don't work is when there's a disconnect between the signature of a constructor and what the class takes. So imagine that I want to make my pair somewhat more intelligent / optimized, and I make a template on type name T, type name U, and I would like to accept Eventually, I would want to like, be perfect forwarding. But that's a distraction. I'll just skip that for now. Imagine that I want to just accept some arbitrary const-ref val1 and const-ref val2. So I'm going to be constructible from anything that I can use to construct A and B, but they could be different types. So I could have something like a my pair of an int and a std string, and I could construct it from an int and a string literal, a const char star after decay. This constructor would allow that to work. However, if I have only that constructor and I try to use CTAD and say that I don't want, a std string to appear out of nowhere, I just want int and const char star like before, this constructor will prevent CTAD from implicitly working. If I try to compile this, I'm going to get an error. The error looks horrible because the compiler is only going to complain about, the sort of microscopic details that it sees. In this case, the error is actually fairly comprehensible. It begins by saying cannot deduce template arguments for my pair because I didn't provide any, and the compiler needs to deduce them, but it cannot deduce. And then it goes on to say, hey, I couldn't deduce what A is, I couldn't deduce what B is, and then the compiler error gets increasingly deranged. It talks about a copy CDOR. I think this is actually a copy deduction candidate. But ultimately, this constructor is no longer good for CTAD by itself because it's disconnected from the template arguments of my pair. My pair is templated on A and B. This constructor is further templated on T and U. There is no direct relationship between these two. So this prevents CTAD from working. However, we can fix it up. We can write a deduction guide, which will look like this. And that's what we're going to be reviewing changes like this in the PR. I can say template type name T type name U. Let's see if I can get this right. My pair, and actually to avoid any confusion, I can choose new names. Let's say X and Y. There's no actual relationship between the names here. My pair XY, arrow, my pair XY, new syntax. Of course, introduced without any keywords because the committee has an aversion to adding keywords. Not always, but in this case, it was done without any new keywords. So this thing is called a deduction guide. It's not a function. It's not an alias. It's not a type def. It doesn't create a new type or anything. It's simply a thing that looks like a template that assists the compiler in deducing template arguments for a class. So when the compiler needs to perform CTAD for my pair, it will consider all of the deduction guides for my pair in addition to any implicitly generated deduction candidates from its constructor. And the deduction guide can sort of rescue template argument deduction and manually instruct the compiler what it needs to do. So in this case, this deduction guide says, hey, if you're trying to construct a my pair from X and Y, then perform function template argument deduction for this, deduce what X and Y should be, and then I'm going to generate the type my pair of X and Y. Most of the time, or often, deduction guides simply follow this pattern. But the types on the right here don't have to be exactly the same. We could say, oh, I actually want like an X star and a Y star for some reason. Or maybe add constants or something. I can construct anything. Or maybe I want a my pair of, wrapper X, wrapper Y. This is also totally legitimate if I had a wrapper class. So this provides the freedom to the programmer to tell the compiler how to handle their class. So if we have this guide, let's prove that this works. I have this generalized constructor that accepts arbitrary T and U. I've got a deduction guide that says, hey, if you're trying to construct from X and Y, that's the type you want to generate. And this will provide that sort of connection that CTAD needs. And then we're actually going to try to construct it. Note that even in the real std pair perfect forwarding case where we accept arbitrary trefref and urefref, the deduction guide just looks like this. It actually performs decay when deduction happens. And that is what is going to take this array of 5 const characters, including the null terminator, and decay it to a const char star. That happens implicitly when Y is deduced. And that goes all the way back to CS+98. That's what happens when you perform deduction for a value parameter. You get decay. So let's see if this works. Let's verify that I've actually saved the file. Yep, we've got the deduction guide there. So now let's compile in 17 mode, and it compiles. So this indicates that the deduction guide was used and repaired this example that did not work as soon as we generalized the constructor for T and U. So that's one example of how a class's design can require manual intervention for CTAD. The more complicated the class is, the more constructors it provides. Usually the more involved CTAD assistance needs to be, whereas the simple examples often work implicitly. So this, let's return to this paper, has found issues. This is Arthur Dwyer and Mike Spurtis, who was involved with the original CTAD proposals, have found cases where CTAD is specified in CS Plus 17 through 20 is somewhat unnecessary, doing somewhat unnecessary things. So they've got an example here that shows, like, here's an example using polymorphic allocators, which is a CS Plus 17 feature. Had to load that into memory. And there is a constructor that accepts these arguments, or that we could choose, but the presence of this polymorphic allocator argument interferes with CTAD. And the reason why is that when you pass arguments to construct an object of a class, as humans, we look at all the constructor signatures and we know which one we want because they have helpful names like allocator. Here, the compiler doesn't know that. With concepts, we're beginning to walk in that direction because the concept says, oh, I only accept, input iterators. So if you give it something like an int, that does not meet the input iterator concept, and the compiler won't even consider it. But in this case, we do not have any concepts constraining this stuff. We just have a deduction guide that says, if I have a stack, I'm constructible from an underlying container and some allocator, and I will produce a std stack of, and then the stack is templated not on the underlying container as its first argument, it's templated on the element type. So we need to reach in to the container, get its type def, and say the stack is templated on the container's value type. And then the underlying container, which includes that allocator information, is the second argument to the stack. So here's an example where CTAD doesn't simply repeat container allocator, it transforms the types a little. So this works fine if you're actually trying to construct the stack from a container and an allocator. That's what we verified when we implemented this stuff and voted it into CS Plus 17. The problem is that if you try to construct a std stack here from a std PMR vector, this is a container here, and this, which is a polymorphic allocator, this does not qualify as an allocator. Yes, the type of address MR does not qualify as an allocator. So the deduction guide removes itself, even though we could have deduced what type we wanted for the stack, because the container provides everything that we need. This constraint here in the standard saying a deduction guide for container adapter shall not participate in overload resolution if it has an allocator template parameter and the thing does not qualify as an allocator. This constraint is needed to prevent other ambiguities. So it is kind of a sort of a pileup of complexity where a patch to fix one emergent bit of complexity in CS Plus 17 has created further issues that we've discovered as we interact with increasingly complicated allocators. That's just sort of life for CS Plus, I would say. Nothing really has gone wrong here. There's just this is the first time that we're sort of retrofitting containers retroactively for class template argument deduction, and we're working through all of the consequences. So it's great that Arthur and Mike have done the work here, and we can now implement the proposed wording. So there's more rationale up here that goes into exactly how things can go badly and how to repair them. But I think we have enough context now to start looking at the PR. Okay, so let's just do a scan of the proposed wording before we start looking at the PR. I can now close this issue. Okay, So we're going to add some global wording to what constrains deduction guides for container adapters. The container adapters being stack queue and priority queue that wrap underlying containers. So previously we said, hey, if the deduction guide has any allocator template parameter, then that thing needs to qualify as an allocator. We just saw an example that actually interferes with some deductions. So now we're going to refine this, and it says if the container adapter has no container template parameter, that means that the only way to get allocator info is from the allocator. So in that case, we need to insist that the thing looks like an allocator. But if it does have a container template parameter, then we should not constrain the allocator thing to look like an allocator because we don't necessarily need it there. Then changes to the actual real containers. Here, this is changing constructors. So this change looks extremely mysterious if you're familiar with only CS+ 14 and below. Because why would you ever modify the parameter of a constructor to say type name, identity of allocator :type, where it's just a struct that takes a type and returns it unchanged? Why would you ever add that extra bit of complexity? And the reason why is that in CTAD, this inhibits deduction for this parameter. This is a sort of trick that has become so common that we now have a helper type IdentityT that does it. This prevents deduction because template argument deduction does not see through the :: when you say type name, identity struct of T : type. So if you're familiar with templates, you'll have encountered that rule. This is now being extended to constructors because constructors now generate implicit deduction guides for CTAD. So when we wrap the allocator in type IdentityT, we're saying, hey, we don't want to use this for deduction, but if we're using it just for the constructor itself, where we know in DEC what the type of the element is and what the allocator is, this has no effect. So whenever you see this sort of type IdentityT in a constructor signature, that's a signal that it's only for CTAD, and we're not trying to interfere with the constructor's actual operation. So we're messing with the constructors that either copy or move from a DEC and provide an allocator object. Same for all the containers: forward list, vector, vector bool, everyone's favorite container, map multi-map, set multi-set, the unordered meows, and that's it. Okay, so that's actually pretty small. There's also a table here of changes that have been implemented accidentally, just because of how various implementations structure their containers and their container adapters. So this is convenient because it shows us what we have accidentally done. Looks like for MSVC, we were actually fine already for all of the associative and unordered associative containers and the some container adapters, but not all of them. The ones that take a comparator, I don't know what the difference between PQ and PD is here initially. I'd need to look up what that is. And the underlying sequence containers, we need to adjust those as well. Okay, yeah, the two changes are stop overconstraining allocators that don't participate in deduction. That's the first global change to the adapters, and then stop deducing from allocators that should not participate in deduction. That's the changes to the underlying containers. There's a second explanation. I skipped over this one, but it's going to be more of the same sort of CTAD scenarios. They can be quite complicated to look through, but if you sit down for a moment and work through how the deduction works, they're not as scary as they seem. So, okay, let's take a look at the PR. We got 10 files changed. I'm going to alt-click to minimize them. Okay, so we got changes to the sequence containers as expected because this overview helpfully pointed it out. We don't need to change the associative or unordered associative due to how they're currently structured, although I do expect to see test coverage for these to ensure that they continue working. Now that I'm looking at this, I'm assuming that PV means polymorphic vector, PD means polymorphic deck. That makes sense. Okay, and then we've got to change to YVal's core, which is going to comment the thing, and then we're going to add a new test, no changes to existing tests. Okay, so nice and isolated. Let's look at the simplest changes first. So we've got, okay, this is being implemented unconditionally. So it's being added to the hasCXX17 list. Do I believe that that is reasonable? I believe so. We have almost, for the 20 and especially 23 cycle, we've been implementing things guarded by standard modes. The idea is that we don't want to disrupt existing code. And secondarily, we don't want to encourage people to depend on stuff from the future too much, but it's not an ironclad rule. We have implemented things unconditionally, like the enable share from this overhaul, especially if it has any possible break impact on users. In this case, there's a very strong argument to do it unconditionally. By implementing this, it's not going to break anyone who wasn't expecting it. We're only making code work that previously didn't work. So at most, somebody could complain, hey, I wrote the CTAD and it worked on MSVC because you implemented this CS+20 paper, CS+23 paper unconditionally. Then I ported it to another implementation and it stopped working because they had not implemented it unconditionally. That is kind of an issue. It's also fairly easy to work around. It's not like somebody would need to massively restructure the code. If they absolutely had to, they could provide explicit template arguments. That's in fact why there's no feature test macro, because targeted workarounds are always possible if you're unsure if support exists. And the fact that it just allows code to work, I think that's a strong enough argument to make it unconditional. We could be, saying, oh, it should only be CS+23, but that would maybe help portability a little. It's really just fixing a defect as far as I'm concerned. Even though it was not formally voted in as a defect report, I think it makes sense to implement unconditionally. So it's being, the other reason why that is convenient is it means that we need less if-defing in our sources. The other thing that motivates us to implement features unconditionally is if it invasively changes an existing feature in a way that would be hard to conditionally turn on and off, then that's an argument for making unconditional. That was the case for the enable share from this overhaul, where, in theory, you could have an if-def, but because it was intertwined throughout weak putter and shared putter, making that improvement unconditional was so much simpler. In this case, reducing the complexity of the CTAD and the constructor signatures seems worth it compared to, oh no, we might accept code that might be non-portable to another implementation. It's also the case, thanks to this table, people trying to do CTAD like this already had code that was being accepted by some implementations and not others. And we, in fact, did not hear about this until from users until Arthur and Mike noticed this. So the status quo was already, you couldn't reliably expect even MSVC to reject all of these. So accepting these ones as well, totally fine. Okay, so this is being mentioned in the 17 list. It is in sorted order. It's got our title case, cleanup title, stop overconstraining allocators, and container deduction guides. That looks good. Okay, so YVal score is good. We know there's no feature test macro. We've got a new test being added. Let's make sure that paper number is right. P1518R2. I'm just eyeballing it rather than doing a search to detect digit transpositions and so forth. That is in sorted order. I do want to detect any typos here because this test list is only used in our internal test harness. So that's good. We match exactly. New test being added. The new test, we got our copyright license banner. This should use the usual matrix of compiler options down to CS+17 because it's unconditional, so that's good. And then we've got a compile-only test being added. We'll review this last. We got the banner there, so that's good. There should also be a compile-only comment that I'll check for real quick. Yes, there is. Awesome. Okay, let's take a look at the adapters first before the underlying containers. That's queue and stack. These are pretty small. So the change that we expect to see for the adapters is this part. Only for the allocator template parameter deduction guides should we enforce the constraint. But if it has a container and allocator, then don't enforce the allocator. Okay, so here we've got Q of container and allocator. We should not enforce that the allocator is an allocator. So the enable if T is being simplified. We've got conjunction V, enable if not, container had better not be an allocator, so that's being preserved. We used to require is allocator alloc, that is being dropped for this paper. That's good. However, the container needs to use that allocator. This will be true for that polymorphic memory resource stuff. So this is good. And then Clang format is wrapping this to a single line. And that is the only guide that takes container and allocator. This is just the plain container, and that's the end of the 17 stuff. Below this, I think, yeah, there's a 23 guide. But this is only for a range of input iterators and alloc. There's no container. So this is good. That's Q. Same to priority queue. In this case, Clang format makes the change easier to review. We are simply dropping the is allocator constraint, but keeping the rest. The predicate had better not be an allocator. Oh, sorry, I was pausing because I was quickly scanning the surrounding code. For this one, we've got predicate container alloc. Because of the presence of the container, we need to drop is allocator, but keep the rest. So the predicate should not be an allocator. The container should not be an allocator. The container needs to use the allocator. This is all good. Let's verify that no other constructors need to be modified. This is predicate container. There's no alloc. This is two iters, a predicate container, no alloc. We've got two iters and an alloc. Two iters compare alloc. Two iters compare container alloc. Okay. This one needs to be modified. We've got a missing change here. This was added fairly recently, I think. Yes, that we just merged a PR. I believe they added this one. So this could have been a silent merge conflict if FSB had started, FSB 4000 had started this PR before that was merged. But yeah, this container alloc one needs to be modified. Let me get that signature. Yeah, searching for like other occurrences that need to be modified, especially when the wording implies what needs to be done, is always important. Okay. The deduction guide below for backtick also needs to be modified. Explanation, as it has both container and alloc. Is the criteria. It has no container and an alloc, so when you have both, you need to change. Okay. The deduction guide below for prior to Q, iter, compare container alloc also needs to be modified. It has both container and alloc. Okay, let's double check that those are the only ones. So pred container, no. Iter, pred container, no. Modifying pred container alloc. Iter, alloc, there is no container. Iter, compare alloc, no container. Iter, compare container alloc, that's the one we mentioned. And that's it for 17. There's no 20 stuff. Okay. This actually corresponds to two constructors, if I remember correctly, both copy and move from the container, but we only need a single deduction guide because the deduction guide performs decay. That's why we only have one here instead of two. Okay, so that's priority queue. Great. Stack. This one should be simpler because it does not have the extra guides that were added for priority queue, but let's look at the context. Okay, so 17 guards the guides. Container only doesn't get modified. Container alloc does. Simplifying the enable if conjunction V. Container had better not be an allocator. We're going to drop is allocator alloc. Keep the uses allocator container alloc. That's good. That's the end of the guides for 17. For 23, we recently added a guide for init alloc, but there's no container, so it does not get modified. And that's the end of all the guides. Okay, so stack and the container adapters look good. Now let's look at the 4 sequence containers. We can do that in alphabetic order. Okay. Let's see here. FSB 4000 is beginning by, for 17 mode, include the type traits header for underscore IdentityT. This is our internal ugly alias that implements type identity. I believe it's actually defined in type traits. We've got a lot of uses. Okay, it is actually provided by type traits. This is technically unnecessary. Basically everything in the STL, especially the sequence containers, already implicitly drag in type traits through a chain of stuff. In this case, it's coming in through X memory. It's not harmful. Pragma once is going to make this basically cost-free. I wouldn't have done it myself, but I'm not going to say, hey, please remove it. In theory, we kind of even should be more disciplined about what we drag in. We are, I would say, horrendously not disciplined about being very clear about what every header drags in. We rely on these long implicit chains and patch them up when we discover, oh, we need to include something else. We've got an include what we use test, or we've got a test that verifies each header is includable standalone, which is what prevents us from accidentally using stuff that we haven't dragged in. So this is fine, even though I wouldn't have done it that way. Okay, so now we've got some conditional code. If underscore has CXX17. Okay, so this is being implemented conditionally. It's not being implemented for 14. Okay, so this is fine. It's not even necessary. Like, the thing is, this conditional compilation could be dropped entirely. I think I know why FSB 4000 did it this way. It's because YVAL's Core 8 said has CXX17 controls this feature. When we're dragging it back, or we're making it unconditionally available, or we're making it available in 17 mode, even though the paper was voted in for 23. The guides are inherently guarded by CXX17. So that's why these changes are being guarded by CXX17. However, I argue that it would be fine to simply drop this if and drop this else case and just say, hey, we're going to change the signature deck for everybody, even in CS+14 mode. And the reason why is because this whole IdentityT thing, it has literally no effect for consumers of deck in the absence of CTAD. Because if you're living in CS+14 and you don't have CTAD available, then you can only use deck if you specify template parameters. And this IdentityT, which is always available to us, it's ugly, will just produce alloc. So it's going to form the same type. The only difference is that it would be observable in IntelliSense. If somebody's like auto-completing deck, they're going to see the IdentityT stuff there. It's not going to change the mangled name of the constructor, because that's going to boil away and we're going to get alloc. So that's going to be fine. It has no ABI impact or whatever, but it would be visible through IntelliSense. However, if somebody is compiling in 17, they're going to see this anyways. We would hope more and more people over time will compile in 17. And having to read through this stuff in the header is a cost to somebody like debugging through this. I think I would actually ask for this stuff to just be unconditional. It's still reasonable to describe it in YVAL's core as being enabled by HES6X17. Or we could move it to the implemented unconditionally. I think describing it as CXX17 seems reasonable. Nobody else will notice this unless they start splunking through this history. I think just for simplicity, because that avoids having to replicate these signatures for all the sequence containers, which are already quite complicated. I guess the thing that would tip the balance is, what did we do for the associative containers? Now I got to remember. So I'm going to look at, let me close this, look at what we did. Let's look at map, which I think is, no, I want Control P, extensively constrained. Okay, let's look at the map constructors. Okay. I'm going to zoom out a little bit so I can see a little more. Okay, do we have any, or did we need to type IdentityT any of these? No, we didn't. So this was happening for free on map, at least, due to how we use type defs. Trying to think, did we have any place that used type IdentityT unconditionally, IdentityT. IdentityT. Okay, we've got a fair number of these. Atomic store. Yeah, but that's not for CTAD. I want something for CTAD. I think we added this from a later standard. I could be wrong. The open signature, that one's an extension. Oh no, the extra argument's an extension. Yeah, this open for something convertible path, we had to decorate that with IdentityT for reasons. We use it in tuple to prevent template argument deduction for myself to avoid ambiguity. This is actually not depicted in the standard. We just had to do it. Same with pair. The comparison operators. Here, the standard tells us to do something equivalent to IdentityT. So essentially, although we don't have this happening for CTAD yet, we already have a number of these in the signatures. I think that the code complexity involved in having this be conditional outweighs it's a worse cost than just doing it unconditionally. So I will suggest that. I mean, the way it's done here is not wrong. I just think it looks like it's more complicated than it really is, and that it's simpler to reason about, oh, we just have an IdentityT there. We need that for the future, but it has no impact whatsoever on CXX14. So, okay, let me add a comment to the first occurrence here. Yeah, this is the first occurrence in deck. Let's see. After I'm thinking about it, I believe that these sequence container changes to use IdentityT should be made unconditional, as they will have absolutely no effect for C+14 compilations except as viewed by, or except for IntelliSense, etc., displaying the actual signature of the constructor. It's still reasonable, or the conditional compilation is adding extra. Yeah, I'm trying to think, do we need to provide a rationale? Yeah, I think I do need to explain my thinking there. The conditional compilation is adding extra complexity to these constructors, which doesn't benefit, or which benefits neither users nor implementers. It's still reasonable to describe this feature as controlled by has CXX17 in MyVal's core H. That can remain unchanged. Okay, proofread. After thinking about it, I believe that these sequence container changes to use underscore capital IdentityT should be made unconditional, as they will have absolutely no effect for C+14 compilations, except for IntelliSense, etc., displaying the actual signature of the constructor. The conditional compilation is adding extra complexity to these constructors, which benefits neither users nor implementers. It's still reasonable to describe this feature as, let's say, being controlled. It's still reasonable to describe this feature as being controlled by has CXX17 in MyVal's core H. That can remain unchanged. Yeah.
Do you think it's worth pointing out, like, this is not wrong? It's just not completely necessary, since, you know, I think they're just trying to be extra conscientious, probably.
That's a great point. Okay, let me edit that in. This is completely correct. But I believe it can be simplified. Okay, how's this? This is completely correct, but I believe it can be simplified after thinking about it and blah, blah.
That seems good to me. I just like to appreciate the attempt to be super, super, following the letter of what we're doing here.
Absolutely, and it helps to note when something is just sort of like a suggestion rather than, oh, I found a subtle issue here. In this case, it's a subtle improvement. So thanks for mentioning that.
Oh, do you want to add applies below on like 9 million things?
Yeah, I think it's reasonable to mention that. Applies below and to the other sequence container files. Okay, let's just double check the rest of these. If has 6617. We're adding IdentityT and then cling format is wrapping. The other nice thing is that it will visually look better because we're going to avoid this detaching of the member initializer list. Yeah, so that's all unchanged. Okay, and in each case, it is only the copy and move constructor. Oh, here it is. Yeah, the copy and move constructor with the additional allocator. Whoop, I didn't want to close the whole thing. Okay. Okay, so we've got deck, Constexpr and then deck_ref. Yep. Okay, so that's good. We've got forward list, also including type traits. Got the same conditional logic. Guard the first one with IdentityT. Yep. The move. The first one gains IdentityT. The no accept is now being detached here and still strengthened. Yep, so that's good. Okay. We've got list, type traits. This occurs to me. Type traits is being conditionally included for CXX17. If we're recommending to make this unconditional, that I should probably mention something about type traits not being necessary. I should do that just as an independent comment. This is correct, but unnecessary. All of the, we're already dragging in type traits through X memory. As we extensively use type traits. The include each header alone provides, or test provides coverage to ensure that we don't get this wrong. Due to my other comment, recommending making these sequence container, so sequence container changes, let's say, making, due to my other comment, recommending unconditional use of IdentityT. I also recommend simply removing the let's say removing the type traits inclusion under CXX17 here. Applies to the other sequence container files. Okay. This is correct, but unnecessary. We're already dragging in type traits through X memory as we extensively use type traits. The include each header alone test provides coverage to ensure that we don't get this wrong. Due to my other comment recommending unconditional use of IdentityT, I also recommend simply removing the type traits inclusion under HES6617 here. Applies to the other sequence container files. I should maybe mention something about how we are horribly undisciplined about include what we use. That is, our product code appears to be completely undisciplined about include what you use, unlike test code or where reversal. Usually in product code, we're extremely strict, and in test code, we're a little bit more permissive, and we're like, yeah, okay, you don't need to rigorously follow literally every convention. There's some we follow, but some we don't always be strict about. In this case, with the includes, in test code, we try to be real strict about including what we need. And in product code, we just, we drag it in through whatever chain, okay. Maybe in the future, we should refine that, but right now, that's definitely the case, that we just assume type traits is omnipresent in the sequence containers. Proofreading, that is, our product code appears to be completely undisciplined about include what you use, unlike test code or where reversal. I would honestly also be fine with just making it unconditional. It's also like it's no cost there. I suppose I can mention that as a final bit. However, if you want unconditional inclusion of type traits, would also be fine. There is no real throughput or complexity cost. Okay, probably a lot of words for just a single include. However, if you want unconditional inclusion of type traits, it'd also be fine. There's no real throughput or complexity costs. Okay, trying to be a little less prescriptive all the time. Okay, so we got deck. We talked about the type traits. Okay, I went back and commented on that. We looked at forward list. List's got the same type traits. If has 6x17, I'm still double checking while we have it, these guards to make sure they're not being incorrectly if-deffed or anything or typoed. We got IdentityT there. This is being wrapped unchanged. Same with list ref, if has 6x17, IdentityT being wrapped. Okay, that's good. Now vector. Vector is interesting because it should have vector and vector bool. 32 lines being edited suggests that it does. We got the type traits. Okay. We've got if has 17. This is being split. We've got IdentityT there. My pair moves down. If we wanted to retain the if else end if here, there would be an additional simplification because if has CXX17, we might actually be 20. We might need to provide the CS plus 20 Constexpr vector that Mia and Misko worked on. But if we're not 17, that means we're 14. And in CS plus 14 mode, there's no way this is going to be Constexpr. So this really could be completely eliminated. We have done so consistently throughout the headers. If we've missed any, that's unintentional. So if we wanted to keep this structure, there would be an argument for dropping Constexpr 20 here. However, since I'm arguing or recommending we should simply make it unconditional, then I'm not going to bother commenting on that. If a 6x17, yep, this is the vector ref. IdentityT this one. Wrap the no except strengthen down. Yep, that's good. Now we are in humanity's eternal nemesis, vector bool. If has 6x17. Constexpr 20, IdentityT, wrap my base right al. This weird bracing is weird. That'll be fixed if we make it unconditional. And then the vector ref. Final change, always try to pay attention to this one. If has 6x17, yep, that's good. Add IdentityT, wrap the no except. It is curious that we don't describe this as strengthened. That's pre-existing. Oh, because it's mandated. It's mandated by the standard. Ha. Okay, yeah, that's good. Okay, so we got vector. Now let's look at the test. Okay, so we should expect to see tests for the adapters and all of the sequence and associative and unordered associative containers. Okay, so we start with our copyright license banner. We've got the usual set of includes. We got deck, forward list, and vector. I'm sort of mentally enumerating all the sequence containers. Array does not get to participate here because no allocator. Got map and set, umap and uset, also including the adapters queue and stack. We've got polymorphic memory resource and utility. I note that there's no inclusion of type traits. I'm being strict here, unlike the product code, so that was making me laugh. Isn't namespace stud? Okay, I'm going to scan down real quick to see if there's any type traits. Interestingly, no. I think I see move sets utility. I believe this is actually a strict set of includes. Very nice. Okay, so this is a compile-only test. So we can simply say, hey, we've got an extern PMR monotonic buffer resource and not actually ever define it. Here's a Sphene tester. This is trying to see what is going on here. We've got a template parameter, template on template class dot class CTR. This is being given container. CTR is container. Okay, both sequence and associative. So we got a container. The test function is calling the helper with 0 and then forwarding the args down. And then the helper function, if it's well formed, I'm looking at this decal type here. If we can form container from static cast args, we'll construct it and return that as auto. If we cannot, then long is less preferred because there's a conversion from int to long, and we'll return void. So this is using classic Sphene. Instead of using is void v, or sorry, instead of using the void t Sphene. This probably could be restructured with void t Sphene in product code. That is overwhelmingly our choice. We do not use any occurrences of function-based Sphene in product code. The rationale being that if we always use the same system for Sphene in product code, we'll end up with consistent code throughout the product. We'll notice any deviations from it as being likely incorrect or at least worthy of investigation. And an important benefit is that if we always perform Sphene in the right way or in the same way, then we are reducing our exposure to compiler bugs. Either the compiler will miscompile them all or it'll get them all right. We have actually seen occurrences where if we do things in a different way, that exposes us to compiler bugs that we otherwise would not have encountered. This was more of an issue back when the compiler was completely untrustworthy regarding Sphene. It has been massively improved since then. So it's much less of a concern these days, but there's still an argument for if you got to do something complicated in the product code, try to do it consistently. However, this is test code. As I mentioned, we are less rigorous about the pattern that we use. As long as we're consistent within a file and following certain global conventions like not saying long int, then I'm happy. In this case, I think it's fine. I don't think I need to recommend some radical rework. I think it could be done. If I were writing, I think it could be done with void t. I think you could still form decal type and ask for class template argument deduction of container here, because you're not actually interested in the type. You just want to see, is it well formed? So these could actually all be static asserts. But then you would need to pass, if you did it with a void t, is just like a struct, you would need to pass like type arguments and then form decal vals. That would be obnoxious. Here are the advantages of using the function-based form is that FSB 4000 can simply write these as functions taking plain old arguments. You can just form the actual function arguments px and address mr and then pass them through and use them in place like that. So even though this part is a little bit more complicated than I generally see in product code, where the void t Sphene avoids the need for this 0 to int and 0 to long pattern, the actual usage is simplified, and there's a lot more usage down here than there is of the definition up here. So ultimately, I agree with FSB 4000's choice to use function-based Sphene here. I think this is good. Okay, so now we just got to make sure that we're testing all the cases. These are essentially taken, if not exactly, very, very similar to the paper. We know that we always need to test the copy and the move with polymorphic memory resource, that addressMR. So that's what's going on here. So we've got test dec using PMR dec. I'm just making sure that we're repeating dec every time. He passes either the PX or move PX, and then this addressMR that's external stores them in auto variable. But since we don't actually care it's returned, we just need to make sure it's non-void. We can say it's maybe unused. So that's what's going on there. And it has to be a named variable, because if we just call the function by itself, void would be totally fine. But insisting that it gets a name will prohibit void, at least until like regular void becomes a thing, which it does not in CS plus 23 yet. Okay, so dec to decs, forward list to forward list, list to lists, vector to vectors, vector bool. Still mentions vector here, but the actual argument is a vector bool. Okay. And let's make sure we got to move each time. Just one. Yes, that's all consistent. Okay, so that's all the sequence containers. Perfect. Let's look at the associative containers. Okay. We've got map of int, multi-map of int, multi-set of int, set of int. This is in lexicographic order, rather than the usual order ISAM, which is map, multi-map, set, multi-set. This is totally fine. Sorted is great. Oh, but we've got a bug here. This is missing move. I was checking individually. First, let's make sure we don't typo any of this, and then let's look at that we've got the no move pattern, and this one's missing. Move PX is missing here. Okay, now that we found this, let's just double check for any other occurrences. See if I missed any above. 1, 2, 3, 4, 5 above. Those are all good. This one's missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, every single other one has a no move followed by a move. So that's the only occurrence. Okay. So back, we just did map. We've got the multi-map, the multi-set, and the set. Okay, that's all good. And now the unordereds. Unordered map, unordered multi-map, unordered multi-set, unordered set. Okay. Then the adapters. Okay, there's some extra tests for. Yes, that compare. Oh, okay. So here I'm running through like why do we see priority queue twice? It's because of that comparator thing. We got to make sure that with the issue that I mentioned where there's one more guy that needs to be updated, we also need a corresponding test. Okay, so there's two sets of tests: priority queue, queue, and stack. Priority queue, queue, and stack. At first, we test just the priority queue being copied or moved, or the deck or the stack, and then the memory resource. So these ones are the simple ones. These look like the sequence containers, the underlying sequence containers. So we got the priority queue backed by a vector. We've got the queue backed by a deck. It needs to be a PMR deck. That's where the PMRness comes in. And we've got a stack backed by a vector. I think at least one of these is not the default. I thought we had two of these defaulting to deck, but in any event, these are actually well formed. Let's see if I remember. CP reference is faster to find. Is it priority queue? I think is the one that's vector. I think is it stack and queue that chose deck, which is not great. I'm not a fan of deck. Yeah, stack defaults to deck. That's what I thought. So here, when the test says stack backed by a PMR vector, it is using a non-default container that's still totally valid for stack. That's totally fine. I see no reason why to insist. No, I see no reason to insist that this be the default. I mean, it's inherently non-default since we're selecting PMR, and vector is indeed the efficient one that stack should always have used. Whereas queue needs to push to the front, so queue kind of should be backed by list. I would write it that way, but using the defaults, I'll also totally fine. I'm sorry. If I were using queue in production, I would back it by a list because I really do not like deck. But for the test, using the default PMR deck. Totally cool. Okay, so then these are a little more complicated. What's going on here? We've got this is constructing a priority queue, but not from another priority queue. It's being constructed from a comparator. We need to include functional for this, technically, and a PMR vector. So this is the comparator underlying container allocator. And then for queue, we give it a deck and the allocator. And then for stack, we give it the vector and an allocator. Okay, so this is good. Let's make sure we mention the adapter here. Priority queue, queue, and stack. Okay, so we need to include functional, and then we need a test priority Q3. And that should do it. Okay, I'll mention, let me double check that there's no functional. There's not. I know it's super nitpicky because we do totally drag this in through, was it X2Def? Very central internal header. But in test code, we try to be strict. A, because it may help us in the module era. B, because it may help us be portable to libcs+ in the future if they want to use our test suite. Technically, we need to include functional for less. Okay. And let's get that missing deduction guide from the priority queue here. So the one that we added, or the one that was tested, was pred container alloc, but we also need to test this. Let's see, where to add a comment. I can add it here because this shows the signatures being tested. We additionally need a test priority Q3 to cover the copy, move. They're not copy move constructors to cover the constructors plural that correspond to the guide that needs to be updated. No, I'll drop that because we've already talked about that. There we go. We additionally need a test priority Q3 to cover the constructors that correspond to the guide priority queue, iter, compare container alloc. Okay. Okay, I believe that's everything. So that is changes requested. Yeah, I can submit this. Okay, I was like, do I write a comment here? But I think the changes have everything. Although I think I can say, thanks for implementing this CTAD paper. Okay. Okay, I believe that does it for this review. We got through a whole review in one session. That almost never happens. Does anyone have questions about the CTAD that we covered, or other scenarios or code that we've looked at here, or anything else that has come to mind? Okay, sounds like no questions. So I think we can call that a video. Thanks for watching, everyone.
Thanks, everyone. I will stop the recording now.